Please welcome Aditya Saligrama and Joey Holtzman presenting lessons from running a product security-focused cybersecurity clinic. For all Slido questions, please reference BSidesSF.org/Q&A and select Theater 9.
Cool. Hi, everyone. Thank you so much for coming. We've been running a product security-focused cybersecurity clinic at Stanford for the last year and a half or so, and we're super excited to share more about that with you guys. So for some quick intros, my name is Aditya Saligrama. I'm a recent graduate of Stanford, graduated back in December, where at Stanford, I led the Applied Cyber Student Cybersecurity Group, which hosts the security clinic. I competed in CCDC and CPTC for several years, including podium finishes at the Nationals. Once I graduated, I joined Formal as a senior software engineer. We empower security teams to enforce least privilege access to production data and infra resources, and we're a sponsor.
Hello, everyone. I'm Joey, and I'm currently a second year studying computer science at Stanford. And I've taken Aditya's place as the president of Stanford Applied Cyber. And I'm excited to share this talk with you today.
Cool. So we're going to start with some framing. So as it turns out, security clinics are not a particularly new concept. And many universities have started their own clinics over the last 8 years. And actually, if you go down a couple of theaters, you can find a talk by Sarah, who is the leader of the Symposium of Security Clinics, an organization that is sort of host to a number of clinics. There's a clinic at Berkeley, for example. There's one at MIT, one at CMU, one by a series of colleges in San Diego, one in Nevada, one in Texas, and elsewhere across the country. They've been popping up over the last decade or so, and they're mainly started somewhat top-down by universities that want to give their cybersecurity graduates an experience of improving the security posture of organizations in the real world. So they're going to partner with local organizations like municipal governments and local businesses to help improve their security posture. They're typically corporate security focused, for example, things like making sure everyone is set up on SSO, enforcing MFA, looking at Windows Active Directory configurations, coming up with incident response policies, and all sorts of other fun corporate information security stuff that is vital and very important to improving the overall state of security in these localities. The thing is that at Stanford, the prototypical local organization isn't necessarily a municipal government or a small business. It's usually a tech startup. At Stanford, as you guys might know, there's a significantly entrepreneurial environment in which many students are interested in starting startups, and many students do go on to found startups, sometimes after they graduate, but increasingly more often, especially with this AI boom, while they are students at Stanford. And so we've encountered a lot of young startup founders who start building their startups long before they take a formal security course, which means that often they are building things without necessarily even having a security mindset or knowing how to secure the products they develop. And at the same time, the products they develop do host a significant amounts of user data. The specific kind varies over time with what students are interested in building. Obviously, right now it's applied AI, but over time, these have tended to host more and more student data, and as a result, there's been a significant challenge with regards to the student startups hosting all of this student data, and then potentially having this being exposed via security vulnerabilities. And that's kind of the problem in which the security clinic started, in which we sort of observed this growing issue, but also realized that we weren't going to be able to stop students from building startups. Neither should we. It shouldn't be necessary to quash entrepreneurial spirit. But yet we need to help these student entrepreneurs, as well as everyone else in the Stanford community, build tech products securely, even if they don't necessarily have a formal security education. And the environment in which this began, we sort of substantiated some of these findings empirically. In fact, I started my security career at Stanford almost by identifying security flaws in student startups, like literally like finding security vulnerabilities and then just sending out vuln disclosures. Probably not the best advised way to do this, not the safest way to do this. And in fact, I even ended up at the wrong end of a lawsuit threat once from a student social media startup at Stanford as a result of this. Didn't learn my lesson, kept doing this, kept filing more and more disclosures with better reception from the startups over time, thankfully, but also realized that this wasn't super sustainable. And literally like finding startups and like sending disclosures, maybe not the best and most efficient way to protect student data at Stanford. So we decided instead that it was better to be proactive and host this somewhat more formally, letting startups come to us and partner with us to let us help them with their security posture. Maybe keeping some of these same elements of vuln finding, but while they were in the room with us and with their sort of full initial cooperation and not necessarily sort of like just receiving a disclosure out of nowhere. And to level set a little bit before we talk more about the clinic itself, I also did want to discuss a little bit about the common vulnerabilities we've seen before and during the clinic. The broadest category of these is probably misconfigurations of backend as a service platforms like Firebase and Supabase, in which the overwhelming model is a client like a web or mobile app can make arbitrary queries to the database. And as a result, it is often incumbent upon developers to write these sort of like static security rules or like row level security to prevent the client from seeing data that they shouldn't be able to see. In Firebase, this is literally by natively using the SDK, and you can just sort of query for like somebody else's data and often get it if they've misconfigured their security rules. In Supabase, it's because Supabase like auto-generates a REST API helpfully for you over your Postgres database. And as a result, any client can arbitrarily make a query, especially if you don't have the row level security rules set up for that. The second broadest class of vulnerabilities is authorization and authentication confusion with APIs, where often these APIs, especially custom APIs, only really check that you're logged in before they let you make arbitrary queries and take arbitrary actions on other people's accounts. So for example, you can cause two other people to like block each other on a social media platform because it's taking in their user IDs as input, but only checking that you're logged in before allowing you to take that action. A couple of other issues include, for example, unprotected GraphQL endpoints in which you can just request the schema from GraphQL, and then that gives you all the information you need to start querying for actual data, and other basic API security issues such as IDOR and flawed input sanitization. And now over to Joey to talk more about the security clinic.
Awesome. So we get a bunch of startups and they're usually at different levels of their maturity of their product. Some of them started maybe a couple months ago. Some of them have been around for a few years. And so I'm going to show you the structure of how we handle these different types of startups to get the best and the most out of the engagement here. So we'll first start actually before the engagement, we'll give the client a worksheet as well as some legal docs before. And these legal docs are just a mutual NDA and MOU that we have. And the worksheet that you can see here on the right, it allows the client to detail the tech stack of their app as well as what it actually does. And this allows us to better understand what their product is so we can focus during the engagement more on the actual security of their product rather than even understanding what it is in the first place. And then second, now once we get to the actual engagement part, we first do just a short little walkthrough, just having the client detail how a typical user would use the app so we can get a better understanding of that. And then we'll go through a threat modeling and infrastructure review. So this will be finding out where the clients could potentially be targeted the most by attackers, as well as going through any of the cloud configurations that they use, because really all of the startups that we have seen use cloud. And so we'll go through and see in their AWS, their Supabase, anything like that, if there's any or what types of misconfigurations there are, and all that. And then next we'll go through a data security consult. So usually most products will have some sort of sensitive data that we want to make sure is secured. And so we'll go through and just see how the users are able to communicate with the database and the backend. And then last, we'll go through my favorite part, which is the live security testing of their product. And this will be typically, the first couple steps will be the first hour of the engagement, and then the last hour we'll leave for the actual live security testing. And then after, we'll go through a debrief, and then later on, we'll send them a write-up based on the vulnerabilities that we have seen, as well as any remediations that we recommend for them to fix in their product. And so now I'll detail steps 3 through 5 a little bit more in detail. So first, in the threat modeling space, we want to discuss with the clients where they're going to most likely be targeted by attackers. And so take, I guess, for example, like a social media platform that we want to ensure that the clients understand where the attackers may focus specifically on. So maybe this is exposing the sensitive information of user accounts, such as emails and phone numbers and whatnot. And so that just as an example. And we'll also go through a bunch of all their infrastructure configurations, because many times there's many configurations in these cloud platforms, and we want to go through and ensure that any misconfigurations are identified and that the clients can then fix them as well. And last, we also want to ensure that in case of a breach or an incident happens within the product, that the clients can also, they can find out how the attackers actually have got in through, and we can do these through like logging system, alert systems. And so we ensure that they have these in place and that they're also configured correctly. Okay, and so now a little more into the data security consult. We'll go through with them and find out the type of data that they're storing and how they're storing it, as well as how the users actually communicate with getting their data through the backend and maybe authorization middleware, and seeing just how that is laid out right now. If it's necessary for the users to be directly connected to the database and have access to that data, and what data those users should have access to and should not have access to, and then also we will advise clients on how to protect that sensitive data that we have identified the best way possible. So in case of an incident, that there is the lowest risk that could happen from that. And so now to the actual security, the live security test. This is where we'll go through the product, and we'll go through all the potential misconfigurations and things that we've noted down previously in the engagement, and we'll actually go into the product and test if these systems are secure and try to find any vulnerabilities within the product. And we'll also verify that what the client has said about their security thus far in the product is what is actually happening, because many times we've gotten clients where they say, oh yeah, we have this authentication for this page or whatnot, and that's actually not the case. So we'll go through and ensure that that is in place. And then at the end of the security test, then we'll go in and check and discuss what we found, as well as any remediations that we recommend for them to fix. Okay, so now I'll talk about some success stories that the clinic has had within the last couple of years that it's been running. So we have definitely seen many startups, many different types of startups in the different domains that they are in, as well as the maturity of their product. We've seen some startups come to us and they've only been there for a couple of months in the startup space. And then we have some startups that have been there for multiple years. And basically in every single engagement that we've had, we have identified some major flaws in their security of their product. And that's kind of helped vindicate our initial motivation for starting the clinic as well. And we're able to both find these flaws before an actual attacker can do so and take advantage of that. And the main kinds of startups that we have seen is firstly these public interest tech startups. So one of them being a startup that would help journalists. We've had one that is a nonprofit that helps that helps nonprofits manage their grants. And then we've had ed tech startups as well. And the second main kind of startup that we've seen are these B2B applied AI startups. If you look in the current Y Combinator batch, you'll see that most of the startups going into that batch are actually these B2B agentic AI. And so that's understandable that we get a lot of those startups as clients as well. And then last, we've also seen a couple fintech startups. So one example being one startup that helped international trade, specifically within Latin America. And then also some biotech startups. So one of them being a startup that helped provide a computational tools and a web interface for scientists to develop these proteins and molecules and enzymes as well. Okay, and recently we actually have expanded a little bit beyond startups. So we worked with a Stanford internal development team, and throughout the engagement, we evaluated their website security and to see if their WordPress websites were securely set up. And we also discussed a lot of their plans in case there was an attacker that was actually able to breach the systems. And we were able to go through that with them in many different scenarios, like maybe potentially some ransomware that could occur or some DDoSing. And then we actually were able to identify some vulnerabilities in their systems, and one being a DDoS. And as well as looking through their logs, we saw that there were a lot of these script kiddie attacks. And so we also gave them some ways to help mitigate against that and overall make Stanford's infrastructure stronger. Okay, and now I'll hand it back to Aditya.
Yeah, and now is part of the fun part, which is detailing some war stories and vulnerabilities we've caught in the startups that we've hosted at the clinic. So one of our very first clients had a edtech startup that had an admin dashboard that was protected only with client-side access control, which basically means that you could load like, app.com/admin. It would block you because there is some sort of access control there. But then you hit the back button in your browser, and then it exposes the entire admin dashboard, and then you can make changes and see sensitive data there. So that was kind of fun. Another startup, this startup came to us in an interesting way, whereas most of our clients sort of email us at our main contact page and ask for an engagement. With this startup, I got a Slack message being like, "We are actively under attack. Could you help us out, please?" And as it turns out, as we did this incident response process, like live there with them in the next hour, we found that they had accidentally exposed their AWS API keys in the front end. And that some crypto mining bot scanner had found these API keys, spawned a number of container clusters that were mining crypto in their AWS account and sending the proceeds back to the crypto mining group. And we had to essentially help remediate that, shut down the IAM rules that the bot was using to create those clusters, shut down the cluster itself, and then sort of like go through their AWS account, see how else they'd exposed resources, and shut everything else down, and also help them communicate with AWS to try to get the $6,000 bill that they had racked up in 2 days as a result waived. So we definitely do some very diverse work here at the clinic. The same startup also had a couple of other issues, including the fact that they had this Python Flask endpoint that could spawn machines up to do various sorts of biotech jobs. And as it turned out, there is a command injection where you could just get remote code execution on their main web server via that. Another issue that we found in sort of a public interest tech, not quite startup, but sort of project, was basically their feature was AI analysis of PDFs. So you could basically submit a PDF or a URL to their PDF and have essentially like that fed into an LLM to get your PDF analyzed. And clearly there wasn't proper validation of these URLs because one thing you could do is you could ask for the EC2 instance metadata service, which would then give you back all the AWS IAM role keys that you could sort of take over the AWS account with. But a more clever and fun exploit that we did with this endpoint was we were able to realize that because tinyURL lets you make predictable shortened links, you could do sort of something like app.com, like enter a custom tinyURL link into this app, and then go to and then have that tinyURL link redirect back to app.com/index URL equals tinyurl.com/my custom link. And with this loop, this app would just try to keep visiting the tinyURL link and then back to itself over and over and over again until it finally ran out of resources and crashed. And so that was something pretty significant we found. A couple of other miscellaneous ones was a fintech company that we could have wiped with their entire company out with a single web request because they had an API endpoint for withdrawals of money that allowed you to enter negative numbers to withdraw. There are numerous startups with their OpenAI API keys exposed in the front end, so you could rack up more big bills that way. And then a last fun one was an admin panel in another startup that they claimed to have gated behind a VPN. That is, if you're not coming from a VPN IP address, they're going to kick you out. And we found that the way they're enforcing this was they're using a Django plugin called admin restrict with a CVE from several years ago in it, where to just blindly trust the x-forwarded4 header, which is supposed to be set by a load balancer, but of course you can set it to whatever you want. And so as a result, you could find their allowed listed IP ranges, set the x-forwarded4 IP header to something within that range, and ta-da, you now have an admin panel. So we've caught sort of a diverse amount of vulnerabilities of very different types here at the clinic, and it's been a very fun experience and also very helpful for these clients who maybe if they deployed these apps in the real world would be finding out about these vulnerabilities in sort of a much more difficult way for them. And now back to Joey to talk about some lessons learned.
Yeah, so there are definitely a lot of lessons we've learned over the last couple of years in the clinic. So the first one being, as what I talked about earlier, is giving the clients the worksheet and the legal docs beforehand, because this allowed us to prepare for the engagement by reading through this worksheet and understanding what the client's tech stack looked like. So we didn't have to necessarily do that during our time with the client, and we could focus more on the security and configuration that they have in their app. And then also clients were really good about this, and this was giving us these test accounts and test data before the engagement. So when we did this active security test, we were able to use a staging environment rather than the actual production environment, and we didn't have to need any compromise actual users that were using the app at all or anything like that. And so now for some tips for you guys working with some early stage startups or other clinics doing that. So the first being that we really, with these startups, we see a lot of commonly used software. So this can be stuff like Supabase, GraphQL. And to check the misconfigurations in this software, it's pretty tedious to do it manually. And so developing these automated tools to automatically check for these security misconfigurations can be a big help and save a lot of time during the actual engagement. Also, another one is that these startups differ a lot between what their needs are and depending on the maturity and the domain of their product. And so really refining those methods before the engagement can really help make the engagement run smoothly and ensure that the clients can get the best out of it as well. And last, something that we've been trying to do, or that we have been doing a lot, is emphasizing to our clients that early stage startups are actual targets to attackers. I think many people think that, the attackers are after these big companies like Google and Meta, but really, as Aditya has pointed out earlier, that these attackers are going after these early stage startups a lot too, and we want to emphasize that that these founders should take their security in their products seriously, and so that'll help them exponentially as they grow as well. All right, and so thank you very much for coming to the talk, and we'll take any questions now.
Thank you, guys. Starting with our first question. When would you consult with professionals regarding your recommendations? How much experience did you have before the clinic? And how confident are you in what you do given your relative experience level?
Yeah, I can take this one. Yeah, so that's a great question. So I can sort of answer initially about the experience level, in which we've been like finding vulnerabilities like this in startups of like the similar stages that we take in for several years. And of course, like one thing that we emphasize is that what we find often is not an actual exhaustive enumeration of possible vulnerabilities that a startup might have in their app. And like the obvious constraint beyond our experience level is actually just the fact that all of these engagements are 2 hours, including all of the review and not just the pen test. And so like we definitely find it appropriate to consult with professionals. We have done that before. But like often what we find is that of the startups that we deal with, the sort of attack surface and sort of the surface area of their app is limited because they're very early stage startups. And so we're able to do sort of a 80-90% pass at it within that 2 hour session. But obviously, like, yes, there can be more vulnerabilities that are more complicated to discover. Often, like what these startups are looking for initially is sort of the first pass of the most obvious vulnerabilities.
Thank you. You mentioned some common vulnerabilities found in your clients' apps. Do your clients generally have a good idea of the principles of secure design? And do you think it's a problem at the education level?
Yes. So I do think that a lot of our clients definitely like do not have very much experience with secure design principles. And one of the things that we try to do in our sessions is sort of elucidate some of the most basic things that they need to know about these security principles. I do think it is an issue at the education level. And, you know, our friend Jack here in the audience has written in the past about, you know, the need for universities to teach security as a mandatory part of CS curriculums. The thing here is that a lot of the founders that we encounter are very, very early in their CS careers. Many of them are freshmen in their first or second quarter at Stanford, which means that even if security were a required part of CS, they just wouldn't have even gotten to it at that point in their educational careers. So yes, like a lot of this can be helped at the educational level. Some of it cannot be just because of how early these people are.
What kind of engagement do you have with other organizations to review and improve your own processes for consultations?
Yes, we've talked to the consortium of security clinics in the past. We've actually gotten a number of recommendations from them on improving our own processes. The idea of sort of legal docs and having our clients sign the legal docs beforehand was actually surfaced by them, and they're helpful in like providing us templates for the clients to sign these documents for.
In our last question, do you consider privacy reviews and compliance with privacy laws, such as GDPR or CCPA, when reviewing startups' apps?
I think we try to look at some of the principles that these regulatory frameworks are based on and try to apply some of the like standards that make sense for these startups. The thing is that a lot of these regulations only really kick in once your app has like 50,000 or more users. And like the apps that we're dealing with by and large have like at most 1,000 users. Some of them have more, but like none of the apps we've dealt with are like up to like the 50,000 user level in which these regulatory frameworks would kick in. So we don't really emphasize that as much. I will say that like, you know, despite these apps having a small user base, the damage that they can do to these users is pretty significant if they host sensitive data. So like our main priority is sort of a pragmatic review of like how they're hosting the data, what their data model looks like, what they consider like sensitive data exposure, and trying to guard against that.
And that's all for our questions. Thanks, Aditya and Joey. Thanks so much.